Hi everyone. Today we're going to be going over sleepy cow herding. Basically in this problem, Farmer John has three prize cows, and these prize cows are Bessie, Elsie, and Mildred. And they're always wandering off on the farm. We're just trying to herd them together, these three cows. You can think of the main line, the main field on the farm as a number line. And basically, the three cows are just scattered, right? And we want them to occupy three consecutive integers. So just counting upwards right next to each other. So something like 7, 8, 9, right, is consecutive. And unfortunately, the cows are sleepy. So basically, he can only make a cow move if she is an endpoint. So either the first cow here, as you can see, or the last cow. He cannot move the middle cow. So um, basically, when he moves a cow, he instructs her to move to any unoccupied integer as long as in this new location she is no longer an endpoint. So pretty much all this is saying is if we're moving the last integer, it has to be somewhere in between these two. If we're moving the first one, it has to be somewhere in between these two, right? So it cannot be an endpoint once we move it. So um, basically observe that every time we move, the cows are forced to become closer to each other, right? So we need to determine the minimum and maximum number of moves possible before the cows become grouped in three consecutive locations. So the input basically has three space-separated integers, and they give the locations of Bessie, Elsie, and Mildred. To be honest, you don't need to know the names of the cows. You just need to know that there's three cows. Sometimes the names are important in other USACO problems, but not right now. So each location is an integer, and here's the range. And the output is basically just the minimum number of moves that Farmer John needs to make to group the cows together. And the second line of output should contain the maximum number of moves he could conceivably make before the cows become grouped together. In other words, we need to find the minimum number of moves to make them consecutive and the maximum amount of moves to make them consecutive. So here's an explanation of the sample and input and output. So here we have 4, 7, and 9, right? So the minimum number of moves is just moving 4 to position 8 because as you can see, there's a one unit gap between 7 and 9. And so if we just move 4 to be 8 here, then we can satisfy the consecutive thing. But basically, the maximum number of moves is 2. So we move cow here, this cow here, at position 9 to position 6, right? And then after that, we can move cow 7 to position 5. So remember, it's just like inching them closer and closer together. And so this might be, obviously this example is pretty easy, but not all the test cases are going to be this nice. So let's go ahead and draw out some other test cases. Okay, there's a few types of cases that we're going to be dealing with, but one of them is just going to be all consecutive numbers. So that means like if we have 7, 8, and 9, that means that the minimum and the maximum is just going to be 0 because we really can't move them. Well, we really don't need to move them, so it's just going to be 0 and 0, right? Now, if we have a case where it's like what we saw, where there's one number and then there's two numbers with a one number gap in between, then we can just say that the minimum is 1, and then the maximum we need to decide with another method, which I'll be going over later. And then if um, it doesn't match any of these two cases, let's say it's something random, like for example, let's say it's 1, 6, and 13, then the minimum is going to be 2. Basically, the reason for this is you can have any three numbers. The gap can be as big as you want it to be. It can be like 1 and then 1,000 and then 2 million, right? I'm just gonna write M. What you can do is you can just move one of these numbers to 3, right? So it'd be 1, 3, 1,000, and then you can move this here. So 1, 2, 3. So with any three numbers, no matter how much the difference is, the minimum is going to be 2. And obviously the maximum is a different story. But yeah, so that's just one thing to remember. And so now let's go over how to find the maximum distance, right? Because that's different for each input, I guess. So let's there's two different things you have to look at to find the maximum, right? And that's going to be basically if you move this here or if you move this here, okay? So let's look at moving 1 into the middle first, right? So it would be like 6 and then 7, 13, and then we can move this to 7, 8, 13, 8, 9, 13, and so on, right? Until we reach 13. So it would be like this. So notice how we have 1, 2, 3, 4, 5, 6, right? So going from 1 to 13 is, or sorry, moving the 1 is going to give us 6, right? And now let's try moving the 13, okay? So let's move it to 1, 2, 6, right? Move the 13 to 2, and then we can move it so it's 2, 3, 6, 3, 4, 6, 4, 5, 6, right? So notice how it took 4 times here. So basically the pattern, right, that you need to know is pretty much if you find the difference, right, then between like any two, like A and B, for example, and you subtract 1, that's going to be the amount of steps it takes for one of the inputs, right, or one of the outputs. So notice how this is 1 something and 6, right? It's going to take B minus A minus 1 to get this to be, consecutive. And for the other one, it's the same thing. It's C minus B minus 1. So 13 minus 6 is 7. 7 minus 1 is 6. And obviously, the bigger one of these two is 6. So that's going to be our max. So for example, for this input, since none of the two have a one number gap in between them, the minimum will be 2 and the maximum will be 6. So that's the method we need to use to find the maximum. And now that we're over that, we can start programming. So as you can see, I already have some things written down. So I have my variables A, B, and C, which are going to show the positions of the cows. And that's pretty much all I have as for um, the initial stuff. Everything else is pretty standard, right? We have our um, buffered reader and our print writer, and we have our separate initialize and solve methods, and then close buffered reader and print writer. So to initialize our variables, we're just going to use a string tokenizer, and then it's going to be in.readLine. And then in order to get A, B, and C, we're just going to take the integer value of the next token and do that for all 3 of the variables because they're all ints and they're all taken in with the same method. So after we do that, what we can do is start programming. So remember that if A, B, and C are consecutive, then we can just output a 0 and a 0, right? So that's because we don't really need to change anything about that because if they're already consecutive, right, there's nothing to move. So we're just going to do out.println 0, and we're going to do that 2 times, right, because we need to do the minimum and the maximum. Now, if it's not this case, we're going to do an else if, and we're going to say if C equals B plus 2 or B equals A plus 2, right? And if this is the case, then what's going to happen is first we need to print out 1 because that's the minimum. But in order to find the max, what we need to do is remember we need to find basically the most amount of times we can go between either A and B or B and C, right? So remember it's B minus A minus 1 or C minus B minus 1. So we need to just find the maximum between those two. So it's C minus B minus 1 and B minus A minus 1. Okay. And then finally, if it's none of these, remember that the minimum is always 2, regardless of what numbers we have. And we need to basically just do the same thing for the maximum, okay? And this is much more easier than manually calculating how much it would take. And one more thing, this should be an A instead of a C. I put C earlier, that's my mistake. If it's consecutive, right, C would equal B plus 1 and B would equal A plus 1. So yeah, and now we can submit. So yeah, that's really all there is to sleepy cow herding. And if you guys have any questions about this problem or would like me to go over a specific problem in general, feel free to leave a comment. And as always, thank you for watching.